In this video, we're going to talk about future value from 6.1. So let me go ahead and give you the formula here. Future value of an investment that has compound interest e to the r t sub 1 integral from 0 to t sub 1 of f of t e to the negative r t dt. So we're told in 79 that f of t is 3,000, r is 8%, which is the same thing as 0.08, and t sub 1 is 10 years. And this 8% is an annual interest rate. So the time in of R and the time of T is the same. So let's go ahead and set this up. Our future value, which I'll just call FV, is equal to e to the 0.08 times 10, integral from 0 to 10 of 3,000 e to the negative 0.08 t dt. This constant can come out here. Future value is 3,000 e to the 0.8, and then 0 to 10 e to the negative 0.08 t, and I need to multiply by negative 0.08 on the inside and divide by negative 0.08 on the outside. So that's going to give me my future value is equal to 3,000 divided by negative 0.08 is negative 37,500 e to the 0.8. And then this is going to be e to the negative 0.08 t evaluated from 0 to 10. So this is negative 37,500 e to the 0.8 times e to the negative 0.8 minus 1. So that's going to be negative 37,500 plus 37,500 e to the 0.8. So 37,500 e to the 0.8. And since this is dollars and cents, I have 45,957.78. And I believe that's good. Let's just check. 45 957.78 is correct. Let's move on to the next problem, 80. And it is the same type of problem. F of t equals 3,000 e to the 0.05 t. R is 10%, which is 0.1. T1 is 5 years. My formula for future value is e to the RT1, interval from 0 to T1 of f of t e to the negative RT dt. So future value is e to the 0.1 times 5 is 0.5. 0 to 5, 3,000 e to the 0.05 t times e to the negative 0.5, sorry, 0.1 t dt. So that's going to be future value 0 e to the 0.5, 0 to 5. Bring the 3,000 out. E to the negative 0.05 t. 0.05 minus 0.1 is negative 0.05 dt. So I'm going to have to multiply by negative 0.05 on the inside, divide by negative 0.05 on the outside. 3,000 divided by negative 0.05 is going to give me negative 6,000. Sorry, 60,000. E to the 0.5. Then I have e to the negative 0.05 t evaluated from 0 to 5 gives me negative 60,000 e to the 0.5 times, put 5 in here, e to the negative 0.25 minus 1. So that's going to be negative 60,000 e to the negative, let's see, 0.5 minus 0.25 is 0.25. Plus 60,000 e to the 0.5. So negative 60,000 e to the 0.25 plus 60,000 e to the 0.5 gives me 21,881.75. Let's go ahead and look at number 81 to finish this up. And it's a little bit of a word problem, but same formula, that future value is equal to e to the RT, 0 to T1, this is RT1, f of t, e to the negative RT dt. So future part A of 81 says to find the future value of $1,200 saved each year for 10 years, earning 7% interest. So my F of T should be 1200 T. Nope, it's just straight up 1200. So my F of T is 1200. And then we have E to the R is, T is 1200, R is 7%, which is 0.07. T1 is 10 years. So we have future value is E to the 0.07 times 10, 0 to 10, 1200, E to negative 0.07 T dt. So that's going to be E to the 0.7, 0 to 10. This is 1200, comes out here. E to the negative 0.07 T dt, negative 0.07 divided by negative 0.07 is going to be 1200 divided by negative 0.07. It's a fraction. This is negative 1200 7 e to the 0.7 e to the negative 0.07 t 0 to 10 0 0 0 0 over 7 e to the 0.7 times e to the negative 0.7 minus 1 is negative 120 0 0 0 over 7 plus 20 0 0 0 over 7 e to the 0.7. So this is 120 0 0 0 over 7 times e to the 0.7 minus 1 in parentheses. This is what I'm putting in my calculator, 120 0 0 over 7 times e to the 0.7 minus 1 is equivalent mathematically to what I have down there. And I get 17378.62. That was part A. Let's go ahead and look at part B. A person who wishes to invest $1,200 each year finds one investment choice that is expected to pay 9% interest per year and another riskier choice that may pay 10% interest per year, what is the difference in return of if the investment is made for 15 years? So that's going to be let's go ahead and clean all this up, because we were only looking at 10 years for the first part, so that number doesn't help me at all. For the second part, so we have a difference of two future values, and the bigger interest rate is going to produce the bigger future value. So we have e to the, and the bigger interest rate here is 10% times 15 years, 0 to 15, 1200 e to the negative 0.1 t dt minus, then we have e to the, and then we have 9% times 15, integral of 0 to 15, 1200 e to the negative 0.09 t dt. So this is going to be e to the 1.5, 0 to, and let's go ahead and pull out the 1200. E to the 1.5, 0 to 15, e to the negative 0.1 t, negative 0.1 divided by negative 0.1 dt minus 1200 e to the, and then 0.09 times 15 is 1.35, 0 to 15, e to the negative 0.09 t, negative 0.09 dt divided by negative 0.09 makes this 1200 divided by 0.1 is negative 12,000 e to the 1.5, and then this is e to the negative 0.1 t, 0 to 15, minus 1200 divided by negative 0.09. So that is plus, because this is minus a negative 1,2,0,0,0 over 9 is, this is divided by 3 is 4, and that's 3. E to the negative 0.04 from 0 to 15, this is 0.04 t. Okay, so negative 12,000 e to the 1.5 times e to the negative 1.5 minus 1 plus 40,000 over 3 e to the negative 0.09 times 15. 1.35 minus 1 here, and this was 40,000, 3e to the 1.35 out here. Okay, so that is negative 12,000 plus 12,000 e to the 1.5 plus 40,000 over 3 e to the 1.35. 40,000 over 3 minus 40,000 over 3 e to the 1.35. So negative 12,000 plus 12,000 e to the 1.5 plus 40,000 e to the 1.35 divided by 3. It's a minus, not a plus, plus 40,000 over 3. And I get 3681.26. And that's correct. And that's it for this video. We'll come back next time and talk about 7.4. And we've got just a few problems there, and that'll wrap up everything for our videos for this course. So see you for the next video.